Welcome to this presentation on the insertion sort algorithm. In the next few minutes, we will explore how the algorithm works, walk through a step-by-step example, understand its pseudocode, and finally discuss its time and space complexity. Let's get started. Insertion sort is a simple intuitive sorting algorithm. It builds a sorted list one element at a time by comparing and inserting elements into their correct positions. A great way to visualize it is by thinking about how we sort cards in our hands. We pick up one card at a time and place it in the correct position among the already sorted cards. That's exactly what insertion sort does. Here is the basic process of insertion sort. We start from the second element of the array because the first element is already considered sorted. For each element, we compare it with the elements before it. If an element on the left is larger, we shift it to the right. We continue this shifting until we find the correct position to insert the current element. By repeating this for every element, the array gradually becomes sorted. This pseudocode describes the logic mathematically. We loop from the second element to the end. The current element is stored as key. Then we move backwards to the already sorted positions, shifting elements that are greater than the key. When we find the proper position, we insert the key. This continues until the entire array is sorted. Let's walk through a quick example using the array 5, 2, 4, 6, 1, 3. First, 2 is compared with 5 and inserted before it. Next, 4 is placed between 2 and 5. The element 6 is already in the right place, so no changes are needed. Then 1 is inserted at the beginning, shifting all larger elements to the right. Finally, 3 is inserted after 2. This process results in the fully sorted array 1, 2, 3, 4, 5, 6. Insertion sort performs differently depending on the input. In the best case, when the array is already sorted, it runs in linear time. In the worst case, such as when the array is reverse sorted, it takes quadratic time. The average case performance is also big O of n square. However, it has an advantage. It uses only constant extra space, making it an in-place algorithm. Insertion sort is ideal for small datasets, nearly sorted arrays, or situations where we need to insert data into a growing list in real time. While it may not be the fastest for large inputs, its simplicity and low overhead make it very useful in specific scenarios. Thank you for your attention.